Disc brake pads consist of friction material bonded onto a steel backing plate. The backing plate has lugs that locate the pad in the correct position in relation to the disc. Calipers are usually designed so that the condition of the pads can be checked easily once the wheel has been removed, and to allow the pads to be replaced with a minimum of disassembly. Some pads have a groove cut into the friction surface. The depth of this groove is set, so when it can no longer be seen, the pad should be replaced. Some pads have a wire in the friction material at the minimum wear thickness. When the pad wears to this minimum thickness, the wire touches the disc as the brakes are applied. A warning light then tells the driver the disc pads are due for replacement. The composition of the friction material affects brake operation. Materials which provide good braking with low pedal pressures tend to lose efficiency when they get hot. This means the stopping distance will be increased. Materials which maintain a stable friction coefficient over a wide temperature range generally require higher pedal pressures to provide efficient braking.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
Warm up the transmission fluid by idling or driving the vehicle. Raise the vehicle and ensuring that it is level and stable. Do a visual inspection for leaks from the transmission. Most transaxles have drain plugs fitted to them that are easily accessible. However, some require that a housing be removed in order to drain the oil. Other types do not have drain plugs and require a suction pump to draw out the lubricant by hand from the filling point. Consult the shop manual for correct procedures for draining the fluid on the vehicle you are working on. Be careful because the lubricant can be hot enough to burn. Locate the position of the drain plug and remove any guard covers if necessary. Select the correct wrench and loosen the plug. Position a large diameter drain pan under the transmission. Clean the plug and then remove it. In the case of an automatic transmission, if there is no drain plug, loosen all the transmission pan bolts with the correct wrench and remove all but 3, the minimum necessary to hold the pan in place. Fluid will flow into the drain pan. Once the fluid stops flowing from the bolt holes, support the transmission pan with one hand and remove the remaining bolts to drain the remaining oil. Look for metal in the fluid, which looks like shiny particles or flakes. If the transmission has been overfilled during service, it could have caused internal damage to components. Also inspect the transmission pan and the residue in it. A small amount of metal deposits is normal, but a buildup could signal excessive transmission wear. If you find larger pieces of metal or clutch material that looks a lot like brake lining material in the case of an automatic transmission, have your supervisor come and inspect it. It is good practice to keep these larger particles in case the owner wants to see them. With an automatic transmission, carefully remove the oil pan gasket. Don't use a sharp tool that could damage the sealing surface. Clean the pan with a lint-free cloth and remove the transmission filter. Filters and screens may be held in place by several screws of varying sizes. Be careful to note any size differences of the screws so you can reinstall them in the correct position. If you have a paper or cotton filter in the transmission, it must be changed every time you change the transmission fluid. Metal filters can be cleaned with solvent or a spray cleaner and reused after air drying. Install the new filter on the valve body as described in the shop manual. Place the new gasket on the sealing surface of the fluid pan. Apply the manufacturer's recommended sealant to the gasket if needed. Replace the transmission or sump pan and tighten the bolts to the manufacturer's specified torque. Over-tightening the bolts may damage the gasket and/or the sealing surfaces. After the lubricant is completely drained, clean the drain plug. Put the drain plug back with a new washer. Use a torque wrench to make sure the torque is correct. Check the shop manual's lubrication guide for the correct replacement fluid specification and the correct quantity. If the filling location is under the hood, you will need to lower the vehicle. Clean the nozzle of a lubricant pump with a clean, lint-free rag or paper towel. Use the pump to put new transmission oil into the filler hole or dipstick tube opening. Pause for a few seconds after each pump to give the lubricant time to flow to the bottom. Stop when the lubricant reaches the bottom of the filler plug hole or to the top of the cold mark on the dipstick. In the case of an automatic transmission, start the engine. Apply the foot brake and move the transmission selector through all the gear selections. This will allow all the cavities in the transmission to fill with new fluid. Place the transmission in the correct gear for fluid checking. Check the new fluid level, adjust if necessary, and replace the dipstick or filler plug.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
Check the tension and condition of the belt around the compressor pulley. An air conditioning compressor uses quite a lot of power, so a loose belt or one glazed from slippage in the past may not be driving the compressor properly. Check the condenser to make sure that it is not clogged with mud or leaves, which will prevent it from radiating to the outside, the heat collected from the inside of the vehicle. The fins on the condenser can be cleaned with water and a stiff brush if necessary. Check that the flexible hoses to the various components of the air conditioning system are not cracked or soft or brittle, and that they are connected securely with no obvious signs of leakage or corrosion around the connections. Some of the hoses may be metal pipes. Check that these rigid lines are securely fixed in their routing positions and also look for signs of leakage at their connections. Some lubricating oil circulates with the refrigerant in an air conditioning system, so look for wet stains around all the hose connections, as well as around the gaskets on the compressor, as these may also indicate refrigerant leakage. Start the engine and then switch on the air conditioner. You should hear a firm click as the compressor clutch engages. Set the blower fan to high and check whether the air coming out of the vents inside the vehicle feels cool. Then switch the fan to its lowest setting and use a stem dial thermometer to compare the ambient temperature with the cooler air coming out of the air conditioning system. The difference should generally be around 20 degrees Fahrenheit or 11 degrees Celsius. although this will vary with different outside temperatures. Let the engine run at around 1500 RPM with the air conditioner on for 5 to 10 minutes. Then feel the hoses on each side of the compressor. The high side, or outlet hose of the compressor, should feel significantly hotter than the low side, or inlet hose.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
Before removing the spark plug, disconnect the spark plug high-tension lead by grasping the boot where it connects to the plug. Twist it and pull it firmly straight out. If possible, use a small paintbrush to clean away any loose dirt or dust gathered around the base of the plug, which may fall into the cylinder when the plug has been removed. The correct tool to use is a spark plug socket. This usually has a rubber insert to protect the plug while it is being removed. Spark plugs can sometimes be difficult to remove, so you may need to extend the wrench handle for additional leverage. Turn the plug counterclockwise to loosen it, and then turn the socket by hand until you can remove it. Remove the spark plug from the socket and clean it, brushing away any light deposits with a wire brush. Check the condition of the plug. If the insulator is cracked, or the electrodes are burned or heavily corroded, or the thread is stripped, then the plug will need to be replaced. If the plug is dirty or oily, this may indicate a problem elsewhere, and you should report this to your supervisor. Check the plug specifications for the correct gap, and measure this with a wire gauge of the correct diameter. If the gap between the electrodes is too wide or too narrow, adjust it by bending the ground electrode with a gap adjusting tool. There are hundreds of different spark plugs, so make sure that any replacement you install has the correct code number for the type of vehicle you are servicing. Replace the spark plug in its seat, carefully screwing it in by hand to avoid stripping the thread. When the plug is finger tight, use a torque wrench to tighten the plug to the correct specification. Do not over-tighten, as this can damage the plug. Apply some silicone lubricant to the inside of the boot at the end of the coil lead and push it firmly into place over the exposed spark plug terminal. Start the engine to confirm that the plugs and leads are functioning correctly and that the engine is not misfiring.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
What is a stroke? It's the movement of the piston from top dead center to bottom dead center. Calling an engine 4-stroke means its engine cycle has 4 strokes. A 4-stroke gasoline engine uses internal combustion, so those 4 strokes must include the 5 key events common to all internal combustion engines: intake, compression, ignition, power, and exhaust. Let's look at a simplified model. The intake stroke starts with the exhaust valve closed, the inlet valve opening, and the piston at its highest point, top dead center. It starts to move down, increasing the volume above the top of the piston. This makes pressure inside the cylinder lower than pressure outside. This higher outside air pressure forces air-fuel mixture into the cylinder. The piston reaches bottom dead center, the inlet valve closes, and the intake stroke ends. Both valves stay closed as the piston leaves bottom dead center. The piston moves up, squeezing the air-fuel mixture into a smaller and smaller volume, which compresses it. That makes its temperature rise, and that makes combustion easier. Just before the piston reaches top dead center, the next key event occurs: ignition. Burning expanding gas generates the force to push down the piston. This is the power stroke that drives the engine. The piston now moves from bottom dead center to top dead center. The exhaust valve opens, and the piston pushes out the leftover gases. Let's look at the cycle operating. Intake takes in air-fuel mixture. Compression squeezes the air-fuel mixture into a smaller and smaller volume. Ignition. The mixture under pressure is burned. Power. Burning expanding gases push the piston down, creating a power stroke that turns the crankshaft. Exhaust. The piston moves upward, forcing burned gases from the chamber. All 5 events occur in this order in each of the engine's cylinders.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
All moving parts in an engine require lubrication. That is, the application of oil to moving parts to reduce friction between them. A lubrication system distributes oil through the engine. A typical lubrication system consists of an oil sump, an oil pump, and oil galleries. The oil is stored in the sump, bolted to the bottom of the engine block. Oil is drawn from the sump by an oil pump. Oil galleries are small passages in the cylinder block that direct oil to the moving parts. Oil that has been pumped to the crankshaft main bearings travels through oilways to the connecting rods. Oil may also be splashed from the connecting rods onto the cylinder walls. A filter is usually provided to remove particles of dirt from the oil. and the circulation of the oil assists with the cooling of the internal parts.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
Under the OBD2 standard, the vehicle's computer monitors the emission systems in two ways. The first is referred to as continuous, where major emission-causing faults, such as engine misfire and incorrect air-fuel mix, are continually monitored. The second is referred to as non-continuous. This is where checks are made only once each warm-up cycle. Each time the engine is started, the computer checks components such as the oxygen sensor, catalytic converter, and other engine systems are functioning correctly. If a fault is detected, the malfunction indicator lamp is illuminated, indicating that the vehicle needs attention. If the condition is intermittent and the faulty system operates normally, the MIL will turn off after the vehicle is operated through 3 warm-up cycles, but the diagnostic trouble code will remain in the computer memory for a set period. If the fault does not reoccur within 40 drive cycles, the code will be automatically erased, but will remain logged in the computer memory as a history code.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
One function of a lubrication system is to reduce friction. Friction occurs between all surfaces in contact. When moving surfaces come together, friction tends to slow them down. Sometimes that's just what's wanted. Friction can be useful. But it can also cause serious damage. It can make metal parts so hot they melt and fuse together. When that happens, an engine is said to have seized. How long an engine lasts depends to a large extent on how well it's lubricated, especially at the points of extreme loading. So lubrication reduces unwanted friction and controls it where it is useful. It reduces wear on moving parts. Clearances fill with oil so that engine parts move or float on layers of oil instead of directly on each other. Much less power is needed to move them, and that's a plus. It helps cool an engine. It collects heat from the engine, then returns it to the sump where it is cooled. It helps absorb shock loads. A power stroke can suddenly put as much as 2 tons force on main bearings. Layers of oil cushion this loading. Oil is also a cleaning agent. It collects particles of metal and carbon and carries them back to the sump. Larger pieces fall to the bottom.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
In a series circuit, components are connected like links in a chain. If any link fails, current to all the components is cut off. In a parallel circuit, all components are connected directly to the voltage supply. If any connection or component fails in a parallel circuit, current continues to flow through the rest. This is one reason why parallel circuits are used in automotive applications like lighting systems. If one lamp fails, current continues to flow through the rest. In a series circuit, all would go out, which could be disastrous. Also, since all components connect directly to the battery terminals, the metal of the vehicle's body can become one of the conductors. One terminal of the battery and one of each component can be connected anywhere on the body or chassis to complete the circuit. This is called an earth or ground connection. It saves a lot of connecting wire. A feature of a parallel circuit is that the voltage across each component is the same as battery voltage. No matter how many components are added or removed, as long as they're in parallel, the voltage across them will be the same as across each other component, including the battery. Another feature of a parallel circuit is that the current flowing in each branch is determined by the resistance of that branch. For this circuit, the resistances of the bulbs are all equal, so the current flowing in each branch is the same. However, the sum of their individual currents is equal to the total current flowing in the circuit. When the resistances are not equal, then the current divides in accordance with the value of each resistance. But the total current flow is still the sum of the currents flowing in each branch.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
The PCV valve is usually located next to the valve cover of the engine or in the intake manifold. If you cannot identify it quickly, check with the workshop manual. Switch on the ignition and start the engine. With the engine idling, pinch the hose attached to the PCV valve hard enough to shut off the supply of air through it. If the valve is working correctly, the idle speed should drop enough for you to be able to hear the change. Alternatively, remove the hose from the PCV valve attached to the valve cover, leaving the valve in place. And putting your finger over the opening of the hose, you should feel suction. Remove the hose and check that it is still pliable and not clogged with sludgy deposits. If the hose cannot be cleaned easily by blowing some air through it, then it should be replaced. Remove the PCV valve and inspect it for deposits. If it can be taken apart, then you can clean it with PCV solvent or lacquer thinners. If it cannot be dismantled, but has restricted operation because of sludge, then replace it with a new one of the same type.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
The rack and pinion steering gearbox has a pinion connected to the steering column. This pinion runs in mesh with a rack that is connected to the steering tie rods. This gives more direct operation. Both the pinion and the rack teeth are helical gears. Helical gearing gives smoother and quieter operation for the driver. Turning the steering wheel rotates the pinion and moves the rack from side to side. Ball joints at the end of the rack locate the tie rods and allow movement in the steering and suspension. Mechanical advantage is gained by the reduction ratio. The value of this ratio depends on the size of the pinion. A small pinion gives light steering, but it requires many turns of the steering wheel to travel from lock to lock. A large pinion means the number of turns of the steering column is reduced, but the steering is heavier to turn. Ratios vary, depending on the type of vehicle. But in each case, the ratio is the same for all positions of the wheels. It is a fixed ratio.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
If a coolant boils, it can be as serious for an engine as having it freeze. Boiling coolant in the water jacket becomes a vapour. No liquid is left in contact with the cylinder walls or head. Heat transfer by conduction stops, heat builds up, and that can cause serious damage. One way to prevent this is with a radiator pressure cap that uses pressure to change the temperature at which water boils. As coolant temperature rises, the coolant expands, and pressure in the radiator rises. It soon rises above atmospheric pressure, and that lifts the boiling point of the water. Engine temperature keeps rising, and the coolant expands further. Pressure builds against a spring-loaded valve in the radiator cap until at a preset pressure the valve opens. In a recovery system, the hot coolant flows out into an overflow container. As the engine cools, coolant contracts and pressure in the radiator drops. Atmospheric pressure in the overflow container then opens a second valve, a vacuum vent valve, and overflow coolant flows back into the radiator. And that stops atmospheric pressure collapsing the radiator hoses.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
Locate the adjustment fastener and loosen it. This is usually on the alternator mounting or on a separate pulley wheel. Move the adjusting mechanism in far enough to allow you to remove the belt. Some vehicles use an automatic spring tension system. In that case, pull the tensioning device back so that you can remove the belt. Check the drive and pulley wheels. Look for cracks and other forms of damage. Check that there is no sideways movement indicating worn bearings. And spin the pulley wheels by hand to check that the bearings are rotating freely. Obtain the correct size and type of replacement belt specified in the workshop manual, and compare it with the belt you have just removed. They should be very similar, although the old belt may have stretched in use. Install the new belt, making sure that it is properly seated in the V-shaped groove or the multiple grooves in the pulley, depending on its construction. If the belt is a serpentine type, then make sure that it is the correct width and squarely aligned in the pulley grooves. If it is not correctly aligned, the belt will be thrown off the pulley wheels. Tension the belt using a wrench and a pry bar. Then check it with a tension gauge. With automatic tension systems, gently allow this to apply the tension to the belt. Start the engine and observe the belt to make sure that it is properly seated and operating correctly. Stop the engine again and recheck the tension.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
Refer to the Vehicle Service Manual to identify the location and type of fuel filter, and the correct procedure for removing and replacing it. If the engine is fitted with an electric fuel pump, locate the fuel pump fuse using the service manual and remove it. Start the engine and wait for it to stop as it runs out of fuel. Switch the ignition off. Obtain the correct replacement filter and components. If the vehicle has a carbureted fuel system, new intake and outlet hoses may have been supplied with the filter. If so, then attach them to the new filter before you disconnect the old one. Loosen the clamps on the fuel line on the engine side of the filter, at the outer end of the hose, and disconnect it. If necessary, drain any excess fuel into the fuel-proof container. Connect the new filter hose and tighten the clamp. Make sure that you have the filter facing in the right direction, with the flow indicator arrow pointing towards the engine. Then remove the old filter and reconnect the new one to the fuel intake. If you do this quickly, very little of the residual fuel in the line should leak from the system. In a fuel-injected system, the fuel is under greater pressure, so the fuel lines are normally made of metal, which are not replaced at the same time as the filter. Using the correct tool, loosen the metal line connectors and remove the filter, catching any leaking fuel in a fuel-proof container. Connect the new filter and tighten the line connectors. Make sure that you have the filter facing in the right direction, with the flow indicator arrow pointing towards the engine. Finally, remember to replace the fuel pump fuse.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
Before working on a vehicle's brakes, attach an appropriate label to the vehicle to prevent accidental actuation of the brake caliper while it is removed from the hub. Safely raise the vehicle and remove the wheel. Remove the brake pads and caliper, making sure the caliper is located safely away from the rotor. Remove the rotor by unbolting the securing device and sliding it away from the wheel hub. Before installing the new rotor, clean it thoroughly in a component washer to remove any storage preservative agents. Clean any dirt, rust, and debris from the hub mating surface. secure the rotor to the hub and rotate it by hand to ensure it rotates freely. Refit the brake caliper and disc pads. Apply the brakes several times to readjust the caliper pistons. Refit the road wheel and safely lower the vehicle. Ask your supervisor to check the brake system pedal pressure, fluid levels, and visual signs of leaks. When the supervisor is satisfied, the vehicle should be road tested by a qualified person to ensure the integrity of the braking system.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
Before removing an oil filter, first refer to the service manual for the vehicle and identify the type of filter required. Make sure that a suitable filter will be available as a replacement. The filter will usually be located on the side of the engine block or at an angle underneath the engine. Some filters have a retaining nut which will require a box wrench to remove it. But most late model vehicles have filters which are threaded cartridges. These are removed with an adjustable filter wrench. Remove the filter and clean the seating area on the engine so that its surface and the surface of the new filter can seal properly. Make sure that the seal from the removed filter is not still stuck to the engine. Confirm the correct part number and obtain the replacement filter from your spare parts supply. It is good practice to fit a new filter every time you drain the sump. Smear a little oil or grease on the surface of the new sealing ring. This will help to make a tight seal, but it will also prevent the gasket from binding and distorting while it is being tightened. Screw in the filter until the two surfaces are touching. To help judge the correct degree of the turn, make a mark on the outside of the filter with a pencil or even a dab of oil. But remember to wipe the oil off again when you have finished. Do not over-tighten the filter. Typically, 3/4 of a full turn is adequate torque for a seal that will not leak.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
Prepare the vehicle by removing any hubcaps or lug nut covers. Loosen the lug or wheel nuts while the vehicle is still on the ground, and raise the vehicle to a comfortable working position. Consult owner's manual for the recommended rotation sequence, and check and compare the type of tire fitted with the original specification. If the original wheels and tires have been changed for aftermarket replacements, locate the recommendations for wheel rotation according to the aftermarket manufacturer. Check to see that radial tires are not mixed with bias tires on the vehicle. If there is a mixture, the bias tires should be installed on the front and the radials on the rear. Note that some vehicles have smaller sized tires on the front, and these must not be rotated to the rear. Normally, the wheels and tires are rotated by moving front tires to the rear and the rear to the front. However, in some arrangements they are moved diagonally, so the procedure should only be carried out in accordance with the vehicle's shop manual, owner's manual, or the type of tire fitted. Refit the wheels. Screw on the wheel nuts or studs. It is a good practice to put them on finger-tight first, before tightening further. Do not put the nut or stud into the socket of an impact wrench and power them on directly. This practice can lead to the wheel nuts or studs going on cross-threaded. Once the nuts or studs are ready to be torqued down, refer to the shop manual for the correct torque and tightening sequence. Typically, the lug nuts are tightened in a diagonal sequence on 4 stud wheels and in a star arrangement for 5 stud wheels until all the nuts are tight. However, there are exceptions, so the manufacturer's recommendations should be referred to. This should be done to a specification of 50% of the recommended torque for the first stage and then to 100% of the specification at the second stage, using the same tightening sequence for the particular wheel.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
First, make sure that the gas flow from both the oxygen and the acetylene cylinders is turned off tightly. The 2 cylinders are secured in an upright position. This is usually on a wheeled trolley. Look at the hose pressure and cylinder pressure gauges on top of each cylinder. Both gauges on each cylinder should read 0. If both gauges do not read 0, turn the main cylinder valve on the top of the cylinder clockwise to close it completely. Then you must purge the system of any gas. To purge the system, make sure the main cylinder valve is closed tightly. Pick up the torch handle and note that it has 2 hoses attached. One hose supplies acetylene, the other oxygen. Turn the oxygen regulator under the gauges clockwise and open the oxygen valve on the handle. This will purge any gas that may still be in the system, and the gauges should both drop back to 0. Repeat this procedure with the acetylene cylinder. The torch handle is the connection between the hoses and the working tips. It consists of a body and 2 taps. It's used for both welding and heating. Different attachments are connected to the handle to enable welding, heating, or cutting. Examine the connections. One connection is marked OX and is for the oxygen hose. The other is marked AC and is for the acetylene hose. As a further safety precaution, you'll find the oxygen connector is right-hand thread, and the acetylene connector is a left-hand thread. Welding tips come in sizes that are stamped with a number. Number 1 is the smallest tip. The larger the number, the larger the tip and the greater the heat that it will provide. Select the tip size suitable for the heating task and screw it onto the end of the torch handle. Hold the torch handle in your hand so that you can comfortably adjust the oxygen and acetylene taps. Position the tip so that it faces away from you. Gently tighten the tip securing fitting. You are now ready to adjust the gas pressure for heating. Look at the 2 valves on the torch handle. The valve next to the oxygen hose controls the flow of oxygen to the tip. Close it tightly clockwise. The valve next to the acetylene hose controls the flow of acetylene to the tip. also close it tightly clockwise. Now that you're ready to use the torch, turn the main valve on the top of each cylinder counterclockwise half a turn to open the valve. The needle on the cylinder pressure gauge will rise to show you the pressure in the cylinder. Turn the oxygen regulator handle clockwise until the needle in the gauge registers 10 psi. Turn the acetylene regulator handle clockwise until the needle in the gauge registers 5 psi. This is your working pressure for heating. Before you light the torch, check the area you're working in to make sure there are no flammable materials or fluids nearby. Workmates should also be clear of the area. The welding flame is not only extremely hot, it also produces dangerous ultraviolet rays, which will damage your eyes. It is absolutely vital that you are wearing the right safety gear, gloves and tinted goggles or face mask, so put them on and adjust them comfortably. Now you are ready to ignite the torch with the striker. The tip of the torch must be pointing downwards away from your body and away from the gas cylinders. Turn the acetylene valve on the torch handle slightly towards the on position. You should hear the gas hissing. Hold the striker against the tip of the torch with the lighter cup between the torch and you. Flick the striker to create the spark that will ignite the gas at the tip of the torch. Open the acetylene valve slowly until the sooty smoke produced by the torch disappears. Then slowly open the oxygen valve on the torch handle. As you open the oxygen valve, you will see the color of the flame change. The pure acetylene flame is yellow, and it will change to blue as you add the oxygen. Continue to open the oxygen valve until you can observe a small, sharp blue cone in the center of the torch flame. This is the neutral flame you need for general heating.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
Most light vehicles use a single plate clutch to transmit torque from the engine to the transmission input shaft. The flywheel is the clutch driving member. The clutch unit is mounted on the flywheel's machined rear face, so that the unit rotates with the flywheel. The clutch unit consists of a friction-type disc with two friction facings and a central splined hub, a pressure plate assembly consisting of a pressed steel cover, a pressure plate with a machined flat face, and a segmented diaphragm spring, and a release bearing and operating fork. The friction disc is sandwiched between the machined surfaces of the flywheel and the pressure plate when the pressure plate is bolted to the outer edge of the flywheel face. The clamping force on the friction facings is provided by the diaphragm spring. Unloaded, it is a dished shape. As the pressure plate cover tightens, it pivots on its fulcrum rings and flattens out to exert a force on the pressure plate and the facings. The transmission input shaft passes through the center of the pressure plate. Its parallel splines engage with the internal splines of the central hub on the friction disc. With engine rotation, torque can now be transmitted from the flywheel through the friction disc to the central hub and to the transmission. When the clutch pedal is depressed, the movement is transferred through the operating mechanism to the operating fork and the release bearing. The release bearing moves forward and pushes the center of the diaphragm spring towards the flywheel. The diaphragm pivots on its fulcrum rings, causing the outer edge to move in the opposite direction and act on the pressure plate retraction clips. The pressure plate disengages and drive is no longer transmitted. Releasing the pedal allows the diaphragm to reapply its clamping force and engage the clutch, and drive is restored.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.
The spark plug consists of a plated metal shell with a ceramic insulator and an electrode extending through the center of the insulator. Threads on the metal shell allow it to be screwed into the cylinder head, and a short earth electrode attached to one side is bent in towards the center electrode. The electrodes are of special alloy wire with a set recommended gap between them. The spark bridges this gap to ignite the air-fuel mixture in the combustion chamber. Spark plugs are identified by 3 different features. These are 1. Thread size or diameter, 2. Reach or length of the thread, 3. Heat range or operating temperature. Spark plugs should operate between average temperatures of around 750 to 1500 degrees Fahrenheit or 400 to 800 degrees Celsius. This is referred to as the heat range. The temperature that a spark plug will reach depends on the distance the heat must travel from the insulator to reach the outer shell of the plug and enter the cylinder head and water jacket. If the heat path is long, the plug will retain more heat and therefore will run at a higher temperature than one with a short heat path.
Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye. Thank you very much for watching. My name is Bill Kiefer. We are MLSProVideos.com. We do YouTube videos for individuals, events, and business. Again, thank you very much for watching. Until next time, goodbye.